You see, when you are running in air, when you are running, okay, on a field, so easy. Now, if you have attempted running in a pool of water before, you see how difficult it is. And that is exactly what happens whenever light is moving from one medium into another of difference in the density. Okay, so when the speed, the direction, the wavelength, and all will change whenever light is moving from one medium into another when the two media have difference in their densities. Okay. Now let's look at when light is moving from one medium into another, what happens? So let's look at light moving from air to glass. When light is propagated, propagation of light from air to glass, what happens? So we have two media. The first media is air. So air, and then the second medium is glass. There is a boundary between the two media or the interface. Now we need the normal. We will need the normal. So when you incident light to the surface, because the density of the second medium is greater than the density of the first medium. And obviously, this becomes what? What is this angle? What's the
Incidence and
so the angle of incidence I. Once the light is moving from air to glass, its part will be bent. Let me increase it rather. Its part, the part of the light will be bent towards the normal. So when light is being propagated from a denser medium into a less dense medium, a less dense medium into a denser medium, it is bent. The part of light is bent towards the normal. So it is deviated towards the normal. Okay. So this is the angle of incidence I. Please, what is this angle? What is this angle?
refraction.
Or angle of refraction R. Now, when we trace the original part of the light, okay, this is the original part. This is its new direction as a result of it encountering a denser medium. So how much is the part of light deviated? It is deviated by this angle. So this angle is what we call sigma, angle of deviation. So where I equals angle of incidence, R equals angle of refraction, and sigma equals angle of deviation. I want somebody to help me get an expression for the angle of deviation, which I'm representing by sigma. An expression for the angle of deviation in refraction.
I minus R.
Good. So good. Look at this whole angle. This angle is equal to this angle. Okay. So it means that the angle of incidence I is equal to the angle of refraction plus the angle of deviation. Therefore, angle of deviation is equal to I minus R. So in under refraction, the deviation is given by I minus R. And under reflection, don't forget we derive that the deviation is given by 180 minus 2I or R. Okay. Now what will happen when the ray is
Missy,
moving? Hello.
please. I don't get the sigma is equal to 180 minus 2i.
Oh, this is under reflection of light. We did this under reflection. Okay, we did that under reflection. If you have a mirror, incident light, reflected light. Okay, this is the normal. So this is I, this is R, but I is equal to R. Originally, the path of the light is going this way, isn't it? It's supposed to go this way. But because of its encounter with the mirror, its path is deviated. So if we want to determine this angle, which is the angle of deviation, what will this be? It's equal to 180. Okay, this is equal to 180 minus 2 times I. This is 2I or 2R. So the deviation, which is also equal to this, is equal to 180 minus 2I. And this is the deviation under reflection of light. And this is the deviation under refraction of light. Akovala, are you okay?
No, yes, but please I have another question.
Okay.
Please, why is it that the reflection we don't take the fact that the polished no the coated mirror is a medium too, but we add like I don't know how to explain it. You see
So
the refraction with
the coated part is also a medium, but the light
okay.
will not pass through. Okay, it's a medium, a glass medium, a metallic, well polished medium. It's a medium. Okay.
Yes, okay.
All
Thank
right.
you.
So okay. So when the light is moving from um glass to air, what happens? When the light is moving from glass to air, so we have the boundary to this time around, this is glass, and the second medium is air. Okay, this is the normal. Now, when light is incidented on the interface, okay, this time around, because this is a less dense medium, the part of it will be deviated away from